It turns out the answer is a resounding yes, and it affects billions of devices. Today, we're diving into how a new paper reveals this chilling reality. Let's get into it. Let's start with today's featured paper, Protocol Prying, Systematic Vulnerability Research in the Apple AirDrop and Android Quick Share Proximity Transfer Protocols, by Arash Al Ebrahim and Nils Ole-Tippenhauer from CISPA Helmholtz Center for Information Security. This is a classic, high-impact security investigation that uncovers vulnerabilities in ubiquitous, undocumented protocols on over 5 billion devices, representing a monumental contribution to real-world systems security. Here's a full breakdown.
First, we built AirFuzz, a custom fuzzer that starts with a seed corpus and feeds it into our specialized mutation engine. This engine intelligently mutates the data before it even gets to the compressor, using feedback on code coverage to systematically discover new vulnerabilities. Next, to complement our automated fuzzing, we also performed a targeted, manual analysis of a different protocol. This involved handwritten tests for both Samsung's QuickShare service and Google's QuickShare for Windows. This table details 6 vulnerabilities found in AirDrop and QuickShare, categorizing them by target, component, class, precondition, and impact. However, the table does not provide information comparing the performance of the vulnerability discovery method against prior work or baselines.
Up next, our second paper out of 10, Socratic Agents for Autonomous Scientific Discovery in High-Dimensional Physical Systems, by Xianrui Zheng and Yang Du from Hangzhou Institute for Advanced Study, University of Chinese Academy of Sciences. This work proposes and demonstrates a new paradigm for AI in science, moving beyond procedural automation to epistemic autonomy, where agents can construct and challenge their own physical models. Let's break down its key contributions.
Here in panel, we see the core of the Ahoy system, an iterative cognitive refinement loop where an AI agent's understanding of an optical system is continuously improved. This process involves the agent making inquiries and a scientific supervisor, represented by Socrates, providing guidance and correction to refine its physical models. Feeding into this, the physics critic agent employs specific interrogation techniques, and panel C shows the utility of each type of question. We can see that causal probing and counterexample challenges are particularly effective at improving the agent's understanding score. Next, this Socratic interrogation loop leads to measurable improvements over time, as shown in the line graph in panel B. With each Socratic questioning round, the agent scores for physics consistency, hypothesis completeness, and uncertainty calibration steadily increase.
Up next, our third paper out of 10, Autoformalization of Agent Instructions into Policy as Code, by Adam Mondel and John H. Brock from Sondra. This paper presents a novel and highly significant approach to agent safety by bridging natural language policy with formal verification, offering a scalable path to provable guarantees that moves beyond unreliable probabilistic guardrails. Let's break down its key contributions.
Starting on the left, we've taken a variety of natural language inputs to define our policies. This includes the system prompt, MCP tool definitions, and even unstructured documents from a policy corpus. Feeding into the main loop, these inputs are used by our policy generator. This component is a frontier LLM that performs the initial translation from natural language into a candidate policy. Next, the generated policy is evaluated in a loop by 2 different critics. A hard critic checks for deterministic issues like syntax, while a soft critic acts as an LLM judge for semantic alignment, with both providing feedback for refinement. The output of this entire process is a verified CEDAR policy set. This formal policy set is then enforced at runtime by an external engine, ensuring the agent's actions are safe and compliant. The guardrail method consistently achieves a 0% unsafe rate according to the Hong and colleagues metric, substantially outperforming both raw and baseline conditions on both datasets. It also maintains a high CEDAR block rate, performing on par with or exceeding the baseline across datasets.
Up next, our fourth paper out of 10, Augmentation with Dilution, a large-scale empirical study of human contributor ecosystems after AI coding agent adoption, by Weixing Zhang and Kozilek from Karlsruhe Institute of Technology. This is a landmark empirical study on a critical, unfolding socio-technical question, providing the first large-scale data on how AI coding agents are reshaping human open-source ecosystems. Let's break down its key contributions.
To isolate the causal impact of AI coding agents, we compare a treatment group that adopted them against a control group that didn't. This table shows a balanced check, comparing the average values for key metrics between these two groups before the study. Feeding into this, we quantify the difference between the groups using the standardized mean difference, or SMD. These values tell us precisely how balanced our covariates are, a critical step for ensuring our causal estimates are robust. Next, we explore how the effects might differ across various project characteristics, which are listed here in the covariate column. The initial balance on these factors, like the number of pulls or comments, helps inform how we interpret their role as potential moderators.
Up next, our fifth paper out of 10, the inattentional gap. Task condition language and vision models omit the safety-critical signals they can otherwise report by Kwon-Soo Shin from Polymath Mind's lab. This paper identifies and names a fundamental, emergent failure mode in task condition models that is critical for AI safety and was previously poorly understood. Let's break down its key contributions.
Let's start with the initial setup, where a model is presented with a scene containing both a specified target and an unspecified hazard. The model is then given a narrow instruction, which we call task conditioning, telling it to only attend to the specified item. Feeding into this, we also look at the unspecified hazard present in the same scene. When the model is focused on its task, we find that the unspecified signal report is suppressed, which is what ultimately drives harm. Next, by comparing the high report rate for the specified target against the suppressed rate for the unspecified signal, we identify a critical discrepancy. This is what we call the inattentional gap, where benchmark safety doesn't equal real safety. Finally, we take this concept of the inattentional gap and test it extensively. We analyze how this gap manifests across different domains, like driving and medical imaging, and across various types and sizes of models. The intrinsic oversight probe, exemplified by Opus 4.8 override, achieves a critical finding report rate of 0.96 to 1.00, substantially outperforming GPT-5 reasoning, which reports 0.00 in constrained tasks. An external dual-process scaffold, combining a task model with an open-ended critic, also achieves a.
Up next, our sixth paper out of 10, AgentX, towards agent-driven self-iteration of industrial recommender systems by AgentX team from Kuaishou. AgentX presents a bold and potentially paradigm-shifting vision for automating the end-to-end process of ML model iteration, moving the field from human-driven engineering to agent-driven discovery. Let's break down its key contributions.
Starting in the agent workflow, we have the brainstorm agent, which is responsible for generating new ideas. It synthesizes information from the data layer's knowledge base to create ranked, executable proposals. Those proposals are then passed to the developing agent, the next stage in our workflow. This agent's job is to take each idea and automatically write the production-ready code needed to implement it. Next, the newly developed code is handed off to the evaluation agent for testing. This agent conducts the A/B tests and converts the outcomes into structured knowledge, feeding back into the trajectory memory. Finally, a key part of the system is the harness evolution layer, represented by these feedback loops. This layer uses the execution data from trajectory memory to continuously sharpen and improve the agents themselves. The current, near-perfect, method consistently achieves substantially higher scores than iteration 1, low quality, across all evaluation dimensions, such as semantic correctness and code style. Specifically for file coverage, the current method shows a remarkable improvement of 2.3 points, or 88%, over the initial low-quality iteration.
Up next, our seventh paper out of 10, RedVox, Safety and Fairness Gaps in Speech Models Across Languages by Beatrice Sivoldi and Luisa Bentivogli from Fondazione Bruno Kessler, Italy. This work addresses the critical and widely neglected issue of safety and fairness in non-English speech models by introducing a novel multilingual benchmark built from real-world audio. Let's break down its key contributions.
To start, this diagram lays out a new benchmark designed to address key gaps in current speech models. A major one is that safety is rarely tested across different languages, which is why the multilingual aspect is so central here. Feeding into this, the benchmark itself is built on several key pillars, as shown in the benchmark details section. It combines speech/audio plus text prompts and, crucially, real users' requests to create realistic test scenarios. Next, we move to the evaluation workflow, which is how the models are actually tested. This process first checks for relatedness to see if the model understood the request, then assesses it for safety and fairness to see if it endorsed harmful content. Finally, a crucial part of this work involved the people behind the data, the real users' requests. The study also looked into the privacy concerns and personal challenges faced by these participants when creating the speech prompts. Voxtrol exhibits some of the largest safety and fairness gaps among the evaluated speech models, with its total percentage of gaps being comparable to 5.4 multi. It shows substantially larger gaps compared to models like Qwen 3, Omni, Gemini Flash, Light 3.1, and Gemma 4, which demonstrate significantly smaller percentages.
Up next, our 8th paper out of 10, Scalable Behavior Cloning with Open Data, Training, and Evaluation by Arthur Alsher and Ongju Kanazawa from UC Berkeley. This is a massive, field-accelerating contribution that directly addresses the primary bottleneck in robot manipulation research, the lack of large-scale, open, and accessible data and infrastructure, and is poised to become a standard resource. Let's break down its key contributions.
Here we're introducing the ABC Stack, a complete open-source toolkit for robot manipulation. It's a full pipeline covering the ABC 130K dataset, ABC models for training, ABC Sim for simulation, and ABC Val for evaluation. Feeding into this stack is our ABC 130K dataset, which is made up of a huge variety of real-world scenes. This is the largest open-source teleoperation dataset, providing 3,500 hours of data across 130,000 trajectories. Next, we use this data in our ABC models pipeline, which provides the infrastructure for training. It takes in camera views and robot states to train policies that can perform complex tasks like folding boxes. To speed up development, we also provide ABC Sim, a large-scale simulation environment. It comes with 400 hours of teleop data specifically designed to correlate with real-world performance, allowing for rapid model testing. Across various tasks and metrics, the pooled ADOLN and DINOV3, ZAN variants generally achieve the highest strict and progress scores, with DINOV3, ZATN leading in mean progress at 67.5%. These top-performing variants substantially outperform others like XAttention and Fast Plus XAttention, though the VLA variants like pooled ADOLN offer significantly lower latency compared to DIV variants.
Up next, our 9th paper out of 10, When Does Combining Language Models Help? A co-failure ceiling on routing, voting, and mixture of agents across 67 frontier models by Joseph Chen from Kaikaku. It provides a simple, powerful, and theoretically grounded ceiling for the performance of any multi-model system, replacing weaker heuristics with an actionable diagnostic. Let's break down its key contributions.
Let's start with the overall flow. A query X of a certain type T is sent to an orchestration system. The ultimate accuracy of this system is fundamentally capped, and this limit is represented by the term 1 beta. Feeding into this, we have what's called the ceiling bound, which is especially important for hard problems like open-ended math. This is where a beta greater than 0 strictly caps the performance of any policy, meaning there's a hard limit to how much improvement you can get. Next, to analyze these error patterns, we can use a single-factor model. As the ceiling bound box notes, even a correctly calibrated one can still underprice the tail, which is the chance that all models fail together. This analysis isn't just theoretical. It's grounded in data from a huge pool of models. We see a whole range of them here, from GPT 5.5 and Claude Opus at the high end, down to models like Llama 4 and 5. Finally, to understand where these co-failures come from, we can look at the realizability bound. This bound considers the resolvable disagreement that a router could potentially overcome, which is directly related to the source and nature of the errors themselves.
Up next, our 10th paper out of 10, Moebius, Serving Mixture of Expert Models with Seamless Runtime Parallelism Switch by Xiaoyu Wang and Seo Jean Park from University of Southern California. This is a top-tier systems paper that solves a difficult, real-world problem in serving mixture of experts models by designing a system that dynamically switches its parallelism strategy. Let's break down its key contributions.
Our system begins with an API server sending requests to a central scheduler. This scheduler, through its switch coordinator, makes a dynamic switch decision to optimize how the model runs on the GPU. This switching is possible because we treat the model weights on the GPU as a single, unified representation. This insight means we can view the same model data through different parallelism layouts without needing separate copies. To make these switches fast, we implement an efficient weights and cache transfer mechanism. This uses fused kernels to quickly reshard the expert weights and KV cache with minimal overhead. Finally, our memory manager plays a crucial role in enabling these rapid switches. It works to preserve different data layouts resident in GPU memory, ensuring they are available with minimal switching cost. Moebius consistently outperforms static TP and EP methods by dynamically switching between them, achieving lower decode token latency across varying concurrency levels. Under dynamic request loads, Moebius is significantly faster, completing tasks in less time than either static TP or EP configurations.
Those were today's top papers. Now let's zoom out. ArXiv received 691 new computer science papers across 55 subfields today. Here are the trending areas shaping the field. Today's research landscape is dominated by AI's creative explosion, deep dives into system interactions, and understanding LLM behavior. The innovation is palpable. Let's take a quick look at each.
Trend 1 of 10. New computational models and analysis. This trend explores novel computational paradigms, advanced analytical techniques, and theoretical foundations across various computational domains. This cluster covers 41 papers. Representative work includes effective removal of operational log messages, an application to model inference, graph isomorphism and representation theory, and a survey of quantum programming languages. Trend 2 of 10. Machine learning for system insights. Apply machine learning to analyze, monitor, and optimize diverse systems for improved performance and understanding. This cluster covers 90 papers. Representative work includes statistical and structural approaches to algorithmic fairness, federated hash projected latent factor learning, and PySib, an open-source Python toolbox for linear system identification. Trend 3 of 10. Optimizing heterogeneous system interactions. Focuses on methods and strategies to improve communication, data exchange, and performance across diverse, interconnected system components. This cluster covers 67 papers. Representative work includes data facts, a metadata schema for structured data exchange in a Nonlinear multi-agent ecosystem, orchestrating black box schema converters, an empirical study of automated, quality-ranked conversion across heterogeneous schema languages, and Halo, hierarchical auction-assisted learning for offloading in Sagin. Trend 4 of 10. Advanced robot manipulation and control. This trend explores innovative techniques and control strategies for diverse robot manipulation tasks, from microscale to complex long-horizon operations. This cluster covers 73 papers. Representative work includes LMODE, rethinking lifelong robot manipulation from a mixture of dynamic experts' perspective. Reinforcement learning enables autonomous microrobot navigation and intervention in simulated blood capillaries, and KRVF, a source-aware semantic voxel world representation for edge mobile manipulation. Trend 5 of 10. Accelerating nonlinear optimization methods. Innovating techniques to accelerate the convergence and efficiency of nonlinear optimization algorithms. This cluster covers 57 papers. Representative work includes a fast convergence resolution of the stochastic eigenproblem using Halley's method and the spectral chaos approach, low-dimensional dynamics of the social compass model, and scaling nonlinear optimization. Many problems, one GPU. Trend 6 of 10. Evaluating computing system economics. This trend evaluates the economic implications, costs, and value of diverse computing systems and technologies. This cluster covers 45 papers. Representative work includes the effortless trap, productive struggle, AI, and the illusion of learning, the open-source economic index of AI adoption and capability, and query cost model calibration in confidential virtual machines. Trend 7 of 10. Large language model behavior and control. This trend explores understanding, predicting, and influencing how large language models operate and interact. This cluster covers 110 papers. Representative work includes KG-Trace, a neurosymbolic framework for mechanistic grounding in antimicrobial resistance prediction, dynamic DLM, dynamic cache budget, and adaptive parallel decoding for training-free acceleration of diffusion LLM, and instruction bleed, cross-module interference in prompt-composed AgentX systems. Trend 8 of 10. AI for creative image generation. AI models are developed for synthesizing, modifying, and understanding visual content, including security and cognitive aspects. This cluster covers 99 papers. Representative work includes C-Origami, an AI pipeline for co-designing flat foldable, visually recognizable origami. LCG, long context consistent image generation with sparse relational attention, and Mirage, protecting against malicious image editing via false moderation. Trend 9 of 10, secure and robust network systems. This trend focuses on developing resilient and protected network systems through advanced algorithms, control, and optimization techniques. This cluster covers 52 papers. Representative work includes NetPTR, optimal differentially private spectral community detection on sparse networks, layered outer loop control for disturbance-robust multi-waypoint UAV arrival, and a distributed quantum approximate optimization algorithm simulator for engineering design optimization. Trend 10 of 10, unmasking hidden patterns with AI. AI-driven methods discover and analyze subtle, non-obvious patterns and structures across diverse data domains. This cluster covers 57 papers. Representative work includes phonetic and semantic analyses of spoken corpora of Beijing and Taiwan Mandarin indicate that the neutral tone is a lexical tone, clue-guided money laundering group discovery, and detecting and controlling sycophancy with cascading linear features.
That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.